Okay, kids. So this is the second question of our math boost. So the question is, even this is a circle geometry question. So the question is to find the angle of BCD. So this is the angle we need to find out. So I'll color that up. So the break point of this question is the moment you realize this is an angle at the circumference. Okay, what? This is an angle at the circumference. So then I'll go and check what is the angle given to me. The angle given to me is an angle subtended at the center. Okay. So I have an angle at the center. I need to find the angle at the circumference. Center, circumference. Center, circumference. So there's only one theory that connects the center and the circumference. What is it? That is this. Angle subtended at the center is twice the angle subtended at the circumference. What does that mean? Angle, this is the center of the circle. Angle subtended at the center is twice, is double the value the angle subtended at the circumference. If this is 200, this is 100. If this is 50, this is 25. This is 120, this is 60. Angle subtended at the center is double the value the angle subtended at the circumference. That is the break point of this question. We need to find the angle at the circumference. They have given to me an angle which is at the center. Center, circumference. Center, circumference. What do we have? Angle subtended at the center is twice the angle subtended at the circumference. If this is 2 theta, this is theta. Most of y'all, even in the theory books, y'all have seen only this figure. So you always go and look for this very figure. No, it can take several forms and it can take several shapes. The most important thing is understanding the theory. What does the theory say? Angle subtended at the center. This is the center. If this angle is 2A, then the angle subtended at the circumference. These two arms are the arms which form the angle. So this is the other one. So this is, if this is 2A, then this is A. Center, circumference. Center, circumference. Similarly, center, angle subtended at the center. So if this is 2B, center, circumference hits here, not this. Why? This arm and this arm are the one which forms this angle. Without this arm and this arm, you can't form the angle. So it's not this, the other one. If this is 2B, this is B. Similarly, the same theory. Angle subtended at the center. If this is 2x, then this is x. Center is 2x, circumference is x. Similarly, imagine that I hold this arm from here and I slowly take it to this side and to this side. So what does it become? When I slowly shift it here, these arms will come to a position like this. When they come to a position like that, the arms will be, the figure will be something like this. Clear? So this entire thing is 2 theta and this will be theta. That is this, turned upside down. If the entire thing is 2y, then this is y. It's like I have holded onto these two arms and I have taken it slowly up. I hope you all can see it. I have holded these two arms like this has slowly shifted it up like this. So that is what has happened here. Similarly, what does the theory says to me? Angle subtended at the center. Angle at the center. What is the angle here? Angle at the center is here. When this line is the diameter in a straight line, the angle is how much? 180 degrees in a straight line. The diameter is twice the angle at the circumference. If this is 180, this should be what? This should be 90 degrees. That's why we say the semicircle angle is a right angle. Semicircle means when we have a diameter in a circle, it cuts the circle into two. Okay? A diameter, what does a diameter do? I'll draw it here. If I have a diameter, what does it do? It divides the circle into two equal parts. So it's an angle like this, 90. That's why we call semicircle angle is a right angle. This is the mother theory of what we studied. This is derived from this theory. It's just additional, keep in mind. That is theory number one. So how do we apply theory number one? I'll go to theory number two also. Theory number two. The sum of the angles around a point is 360. When we have a point around it, the total angle is 360. No matter to how many pieces is it divided. This can be X, Y, Z, A, and B. X plus, Y plus, Z plus, A plus, B is how much? 360 degrees. Even if it is divided into 1,000 parts, around a point, it's 360. It is fixed. It will not change. Keep that in mind. So similarly, in this question, you don't even have to bother about this triangular section. You can easily forget it out. We don't need it at all. Why? I need to find this angle. To find that, what do I need? I need this entirety. Similar to what? Similar to this. Just upside down, that's it. So if this 150, how do we find? At 360 minus 150 degrees is how much? 210 degrees. So that means this is how much? 210 degrees. This is 210 degrees. What does our theory say? Angle subtended at the center is twice the angle subtended at the circumference. If this is 210, half of 210, how much? DCB or BCD equals, sorry, I'll write it the other way. DOB reflex equals 2 times BCD. So BCD equals 210 degrees divided by 2. So BCD equals 105 degrees. So that is the answer. Always make it a habit to box the final answer. Okay.